All right, 5.2, congruent polygons. So we're going to review proportions. So for number one, you can see they're kind of lined up, laying the same way. So, whoops, you can see these parts correspond to each other and these parts correspond to each other. Now you might be able to see right off the bat what the situation is, and that's fine. It won't always be this easy, but you can see the big one is 2 times the small one. So you can already probably see that x is going to be 9. But here's the math behind it. Okay, we set up 2 fractions equal to each other. Now, I prefer to set up a word wall on the outside and just use terms that make sense, like, you know, small and big and, you know, side and base or bottom or whatever you want to put. And then it makes it easy to fill in, because what happens is people will put, you know, x over 18, but then they might put 75 over 150, or sometimes they put 150 over 75. This keeps you from making that mistake. So see, x is the small side, and 18 is the big side, okay, on the bigger triangle. The smaller base is 75, and the bigger base is 150. Now again, if you see this relationship right here, you know, is 2 to 1 or 1/2, you can just solve that. But mathematically, the way we do it is cross multiply. So 150x equals 18 times 75. Okay? And if we do 18 times 75 on the calculator, we get 1350. So 150x equals 1350. And then when I divide by 150, I will get 9. All right? So same thing here, 2 equal fractions. Again, I like to set up a word wall. You don't have to do this. I just think it makes it easier, less chance of a mistake being made. So, again, I'll just put small and big. You can put big over small. You can put the size over here, whatever you want. It doesn't matter. It'll all work out. So I seem to have the base and the, you know, you can call it the slant or the diagonal or whatever you want to call it. So the small base is 3. The big base we don't know, right? The small slant is 5, and the big one is 115. Okay? Now, once again, you might see, oh, 5 goes into 115, and if you just figure out how many times that is, you can multiply 3 by that same number. But if it isn't that obvious to you, then it's 5x equals 115 times 3. So 5x equals 345. And then when I divide by 5, x equals 69. Okay? Whoops. So, on to example 1. Write a congruent statement for the triangles. Identify all pairs of congruent parts. Okay, so what we need to do is match up the sides. So most people like to go 1, 2, 3. Some like to go alphabetical order. It doesn't matter. Okay, so if you go alphabetical order, you might say JKL. So triangle JKL. But then what you need to look at is J has 2 marks, K has 3, and L has 1. So we need to go in the same order on the other triangle. So 2, 3, 1. So 2, 3, 1. TSR. If you wanted to go in order numerically, you might say LJK. And then over here it'd be RTS. Well, look at that. LJK, RTS. They correspond. And remember the other little trick we talked about earlier in the year, once you know that setup, you can do this and know which parts easily correspond to each other, which we're going to do right now. So, sorry about that. Angle J corresponds to angle T. Angle K corresponds to angle S. And angle L is congruent, corresponds to angle R. Now, I think this little setup up top helps when you're doing the segments because it's very easy. If you say JK, that's going to be the same as TS. So line segment JK, it corresponds or is congruent to TS, and you got to keep the order the same. But here's the nice thing. If you do KL, then that's going to be SR. So KL is congruent to SR, and the order is easy to not get mixed up. And then if I just do JL, then that's going to correspond to TR. You can also use the picture. So JK, that was going from 2 to 3, so 2 to 3 is TS. All right? Or if you look at here, this mark here and this mark here line up, all right? And therefore, they both are 1s. And then these are both 2s, so those correspond. And these are both 3s. They both correspond. I prefer this method just because it gets the order lined up perfectly and easily, but whatever works for you. All right, in the diagram, DEFG is congruent to SPQR. So again, I like to put the SPQR above this or below it, just to remind myself what matches up. All right, so find the value of X. So right here, we have an X, and that's in QR. So what corresponds to QR? That would be FG. So we can say 2x minus 4 is equal to 12 because QR lines up with FG. They're the same segment. So I'm going to add 4 to both sides, divide by 2, and get 8. Find the value of y. Well, y corresponds to this angle here. Well, there's also an x in there, but we know what x is. So we can rewrite this as 6y plus 8, because we know x is 8. Now, what corresponds to q? We look up at the top, that's f. So this and this are the same thing. So we can say 6y plus 8 is equal to 68. Subtract 8, and I get 60. And divide by y, divide by 6, that's silly, and I get 10. So, especially when they're kind of spun around this way and reorganized, it's kind of hard to line them up visually for some people. Some people can just rotate their head and see it. Other people, it's difficult. So this way of lining them up and seeing what corresponds really makes it easy to work your way through it. Kind of like a road map. All right, you divide the wall into orange and blue sections along JK. JK is right here. Will the sections of the wall be the same size and shape? Okay, well, let's see what we got here. This corresponds to this. This corresponds here. I'll do what I did before, different shapes. And this corresponds here. We also know that this line right here is equal to itself. Okay? So let's see what we have here. We know that AB and DC are parallel. Yeah, we know that by the lines perpendicular to a transversal theorem, which we learned previously. Okay. that makes JK, okay? JK, once again, is congruent to itself, all right? But this is also the transversal right here, which means angle 1 and angle 4 are congruent because they are alternate interior angles. And the same thing for 2 and 3. All right. So what we have is what's called parallelogram. AJ KD is congruent to CK, and we're going from towards the transversal, so we're going to go towards the transversal here, then travel down the transversal over to the other shape right there, side corner right there. Sorry, losing my words. All right. All right. Example 4. In the diagram at the left, also known as the right, show that triangle PTS is congruent to triangle RTQ. All right, so notice we have parallel lines, okay, which makes PR a transversal, okay? So that makes this angle and this angle alternate interior angles between the two parallel lines, if you see it that way. And then SQ is also a transversal, so that makes this angle and this angle alternate interior angles. So angle P is congruent to angle R, and angle S is congruent to angle Q, and they're both because they're alternate interior angles. We also know that these angles are vertical angles. So angle PTS is congruent to, now you want to be careful here, if we're starting at P, then R, you got to start over here with R. Angle RTQ, because they're vertical. Okay, so since all the parts line up and match up, we know these two triangles are congruent. All right, so here's some things, some new math gobbledygook. So properties of triangle congruence. Triangle congruence is reflexive, symmetric, and transitive. So for any triangle ABC, then obviously ABC is congruent to itself. Symmetrical. If ABC is congruent to DEF, flip it. DEF is congruent to ABC. And transitive. If ABC is congruent to DEF and DEF is congruent to JKL, then you kind of leapfrog over and say ABC is congruent to JKL, like we've already done before. Same concepts. Third angle theorem. This basically says, since we know that triangles add up to 180, all right, and if we know these two are the same and these two are the same, they're going to add up to the same number, and whatever's left over will be that third angle, so this has to be the same. So if we know two angles, the third angle has to match up. Okay, so let's look at this bad boy. For me personally, I sometimes have trouble looking at this, so I will do this and do A, C, D, and label what I have. So this is 30, and this is 45. Okay, and then I have this triangle here, which is BDC. Okay, and I know this is 45, and we know that these two are equal, so this is 45 up here. and these two angles are marked congruent. So that makes this 30 here. So the missing angle has to be the same on both. So 45 plus 30 is 75, and 180 minus 75 is 105. So angle BDC, which is this overarching angle right here, is 105 degrees. So personally, I need to separate that drawing out because my eyes get confused and it's hard to tell. All right, exit ticket. You're gonna do this on your own. Use the information in the figure to prove that ACD and CAB, there's no E there, are congruent. Okay, look and see what kind of parts match up. Okay,